You're looking at a jukebox that I recently printed on a Bamboo X1C printer. This won an award on Maker World in a music box contest. It was originally designed for a music box that was installed up here, a wind-up music box. I wasn't too keen on the music box idea, so I took the design and modified it and added a 2-inch speaker here and a embedded ARDUINO system to play MP3 music. So today I'm going to show you how to download this design from the author who made the jukebox, and then we're going to bring up Bamboo Studio and I'm going to show you how to modify the parts. I can't host the modified parts because the copyright on this is such that he does not allow remixes, but I can certainly show you how to modify it. So what we're going to do is, if we look under the hood, what I've done is I've added a LED ring to it, and we have an 8266 board, a MP3 music board, and USB-C power. So any sort of a phone charger can power this. It draws less than a ½ amp of power. So the walkthrough will show you how to mount a speaker. This is a 2-inch speaker inside of here. And I'll show you how to modify the base to mount the ARDUINO board, and I'll provide a spacer in the design so you can cleanly mount these two boards together. And I've got a schematic for the wiring. And then eventually I will show the ARDUINO program on how you compile the code to get it installed on the 8266 board. These are the parts you're going to need. I got all of these parts from Amazon. Most of them, or some of them, can be substituted out. You don't need that exact LED ring, but you definitely, if you want to use the existing source code, you want a 2812B type. The speaker, I recommend using the speaker. I think it sounds pretty good, and I can give you the dimensions and how to do the cutouts for it. If you pick a different speaker, you're going to have to measure everything. The JST plug is optional. That's if you want to disconnect the speaker, which is easier to work on the jukebox when you pull the lid off. The music board, you have to get that DY-SV5W board. That's the only thing that's going to work. It has a micro SD card on it. You will need to provide your own memory card though. It's a 5-watt amplifier. You will also need some sort of an ARDUINO board. I used the 8266 because I had several laying around, and mine were the older type with the micro USB type plug on it. You can definitely get that board today with a USB-C connector. The entire jukebox will be powered by a standard phone charger, USB-C phone charger. And that DIY female USB-C is something you'll need so you can make this jukebox where you can plug or unplug the cable for powering it. Using your browser, we want to go to Maker World, and we want to load the jukebox into Bamboo Studio. So pick your printer and load it up. And then we want to go to this link and load up the bracket for the ARDUINO board into Bamboo Studio. So load both of these files into Bamboo Studio. I will provide the links to both of these projects in the video description. Alright, so I've got Bamboo Studio loaded, and the first thing you want to do is make sure you've got the right printer selected. So in my case it's the X1C, so I'm going to change it to that. And we're going to have to change several parts on this project. So the first thing you want to change is this first part here. Actually, all the parts. We need to scale this to 150%. The jukebox is too small, and to put a decent sized speaker in there, we want to make it bigger. So every part needs to be scaled to 150%. It's very easy to do. You pick a plate. See, like here, you just click somewhere on the plate. So this dark plate is now selected. Right click it, say select all. That picks all the parts on it. You go over to this button here, the scale button, which is that box with the arrow. Press it. Make sure this green box is checked for uniform scale. Go to the X here for scale and key in 150 and press enter. That makes everything bigger. So now the only kink we've got is it bumped everything off the plate. Nope, it's not a big deal. We're going to rotate this around so we can see how it fits on the plate. We're going to put it right on the edge. We're going to move these guys over. We're going to move this over. And make sure this part here does not run into where it does the calibration print. So you can just move these in the center. And this is good. So now this will easily print on one plate. So we want to do this for each plate. We'll go over to plate number 2, the main and bottom light bar. We'll select it. We'll say select all. Scale, 150. Press enter. And same issue, you just have to move the parts around. Okay. I'll do one more. Right click, say select all. I'm going to hit the scale button. 150. And let's make sure that fits. It does. So we're good. And so you do the same for all the other parts. Right click, select all, scale, 150. Click the plate, select all, scale, 150. Oops. Over here, click, right click, select all, scale, 150. So now we've got all the parts scaled up to the size. Now that we've got that done, we need to modify some of the parts. The main part that we need to modify is for the speaker. So what I like to do is let's create a new plate. That's this box over here, the grid. Just click that. We've created a blank plate. Let's take this part here. This is where the speaker is going to be mounted to. Let's select it. Let's clone it by right-clicking. Hit clone. Just one. And it'll automatically drop it on a new plate. So now what we're going to do is we want to cut a hole in this. If you don't cut a hole in this, the speaker is not going to sound good trying to go through that piece of plastic. So cutting a hole is fairly straightforward. We select the part, we right-click it, and we're going to say add a negative part, and then we're going to add a cylinder. Don't worry about this message, just click OK. Now we've got to make this the right size. So if you're going to use the speaker I used, diameter of that speaker is 50.6 millimeters. So we're going to pick this part. We're going to again go to the scale function. We're going to, instead of scaling it, we're going to use a size function. We're going to say it's 50.6 millimeters. Press enter and make sure this green box is checked. You press enter and now it makes the entire cylinder that diameter. And it's a negative part, means it's going to cut. So now we just move it to the speaker grill. Rotate this around so you can see what you're doing. Let me slide this more into the center. And just get that centered as close as you can where it looks good. Looks like it could go a little bit more there. All right. And you're good. Now if you want, you can look at the bottom of it. You should see it cutting through the bottom. That's exactly the view you want. That means that when you go to print this part, it's going to create a hole in that part. All right. So now that we've got that done, let's go to the first plate. We've got an issue that you don't have to fix, but I did. I didn't like it. This thing is designed for a music box. So it has these holes in it for the music box, for the screws and for the wind-up piece. I want to fill these in so that there's no, hole there. So what we want to do is we're going to make some cylinders to fill in those holes. So you're going to click the plate. We're going to right-click. We're going to say add primitive. we're going to pick a cylinder. Let's change the color right now. So let's go over to the color. That's this color painting tool. I'm going to pick 6 because that is the color of that part. I'm going to then pick the fill option. I'm going to fill it in. I'm going to make sure it's all that red color, which it is. We're going to hit return. Now it's too tall, so make it 2 millimeters high. The way we do that is we go to the scale function. We're going to uncheck uniform scale and just make this 2 millimeters, the z-axis. It's going to make it fairly flat. Now that we've got it flat, right-click it again and clone it. Since there's 4 holes, we need 3 more of these. So now we've got 3 of these things. And let's lean it over correctly so we can see it. And just put them over the holes. Now let's slice that plate to make sure the white goes away. And it does. So that's just a little bit of a weird kink in Bamboo Studio, why it still shows the tower. So as you can see here, you might still see a slight bump. I couldn't get it exactly to the right height. I wasn't sure exactly how thick that plastic was, but 2 millimeters is really close. So at least you won't have holes in that outside plate so that you don't see it from the back. So let's go back to prepare. And we want to slide over to the inside part of the music box, this one here. The reason why there's an inside shell and an outside shell is they want you to print this in pure white. It acts as a reflector so that the LED inside reflects the light around nicely. Because if you do a dark red like this, the LED is just going to get lost in there. It's not going to reflect and it doesn't look as good. So this white part needs the same cylinders as this one. So we're going to pick someplace on the plate. We're going to right click, add primitive, add a cylinder. In my case, I made this pure white. I don't know why it's showing gray right now. So let's just pick the white color. And I'm going to paintbrush it. I'm going to return. So now I've got a white part. So now we're going to scale this part. We're going to go over to scale. Make sure uniform scale is turned off. Go to the Z and change the height to 2 millimeters. Press enter. Now clone it. Right click, clone. Same thing, there's 4 pieces, so we need 3 more. And then just drag the pieces over the hole. That'll fill in the holes. I was slightly concerned that this center red dot could interfere with some of the speaker, because this grill goes over the speaker where that big hole is. And this is a solid piece here. These 4 holes on the side are cut throughs. So I want to have a clean hole in the middle instead of this red dot. So it would be the same thing. We're going to pick the part. We're going to right click. We're going to add a negative part because we want to cut a hole. We're going to do another cylinder. Don't worry about that message. In this case, I believe the number was 11.5. So let's go to scale. We want to turn on uniform scale. We want to keep that as a circle. So make this 11.5 millimeters. Now drag that over the hole and get the angle right so you can see it. Now in this case we have a weird situation. It's floating, no big deal. Go over to the move tool. That's these things with the 4 arrows. Press it. And take the blue arrow. Make sure the cursor is highlighting a number. If you have it too far to the left or right, see how it doesn't show a number? Make sure it's directly over the cursor so you see a number there. And then just pull that down about 50% of the way. And now you can see it's going to cut a hole through the bottom. So now we hit return. And it's the same thing. Center this so that that circle is completely covering that red dot. And it looks good. Actually, maybe not. And what you can do is, if you're having a problem aligning that 100% correctly, make the hole a little bit bigger. So if you can't get it aligned with 11.5, make it 11.7 or something until you get that completely covered in so it cuts a hole through the grill. For the last modification, we need to modify the base. So we're going to create a new blank plate by going over here to the grid, click it. Let's bring it over here to center it up. Let's go to the base, this piece here. Click it, right-click it, clone, one copy, drops it on the new plate. Now we're going to go to the other project that had those supports that I had you load up. So go to the other Bamboo Studio on your taskbar. We're going to take this part and bring it into the base of the jukebox. We can't copy paste this, so we have to export it and import it. So pick the part, right click it, and say export as 1STL. Pick some sort of a name like XYZ123, something unique. Press enter. Go back to the other project. Now we're going to do an import. Go to the file menu in the upper left. Import, the first one here with all the options. Pick XYZ123. Now that we've got the part here, we're going to need to line this up inside this cutout. But we need to measure it correctly, and I don't like the measuring tool in Bamboo Studio. So we're going to make a simple ruler. Right-click somewhere on the plate. We're going to add primitive. Then we're going to add a cube. Let's go to the scale function. Let's make this 36 by 5 by 5. And press enter. Let's rotate this around so we see the top of that more clearly. We're going to take this. This is just a temporary part. We're going to put that right in the center of this circle here at the 9 o'clock position and just get it approximately against that edge. Now take the part that you imported. This is going to hold the 8266 board. Drag that up against that temporary measuring stick. You can rotate this around. If you don't get this exact, it does not matter. This is just an approximation so that this thing will not hit the speaker when you put the top on, and it leaves enough room in the back. So once you have this approximately lined up, take this temporary ruler, drag it out, right-click it, and delete it. Now we need to merge these two parts together so it doesn't accidentally move. You can't do that from the right-click menu. So click the whole part so it's all that grayish color. Come over here to the left side. And if you notice, this is plate 9. Look for plate 9 over here. Here's plate 9. Here's that XYX file that I exported to. Hold down the Shift key and then click that. Once they're both highlighted like that, right-click and hit Merge. That now merges both of them together, and now see if we drag this around, the support moves with the base. The last step we have to do is cut a hole for the USB-C connector. So click somewhere on the base, right-click, say Add Negative Part, add a cube, go to the scale function over here, and enter 15 by 12 by 4.2. Press enter. Now we have this little cutout here. Just for now just drag it somewhere so it's 50-50 about between that edge. Once we have that done, rotate this around so you can see it better. Now you're not going to be able to move this up and down, so you use the Move tool. Go over to Move, grab the blue cone there. Make sure you see those digits below the cone. If it's to the left or the right, you don't see those digits. Get it over the cone, drag this down so it's about in the center, and then hit Return. And now we've got a cutout for the USB-C connector. This was a change I made after the fact. If you want to add a switch to your jukebox so you don't have to turn it on and off by unplugging the USB-C cable, you can add a rocker switch. Select the base, right click, add a negative part, do a cube, go to the scale function, and make sure uniform scale is unchecked. And we're going to do 30 by 13.5 by 8.3. That's going to create a cutout for the rocker switch. Rotate this around so you can see better where you're going to put it. Put it about there. It doesn't have to be exact. And then take the Move function, which is these 4 arrows. Grab the cone, the blue cone, drag this down. Hit Return. And if it's not exactly right, reselect the Move tool and click this to get it exactly centered. And again, it doesn't have to be exact. As long as it's close, it'll be fine. So make sure it cuts all the way through, because this base gets pretty thick over here. So make sure it's cutting through all this way. And now you have a rocker switch. Go back to my project where you have the parts for the mounting of the Arduino boards. And since this is now merged on the base of the jukebox, we don't need to print this. So select the part, right click it, delete it. Print these two parts, and I recommend that you print the pin with a brim. So once you have all your parts modified, the one thing you want to do before you start printing is obviously replace the parts on the plate. I forgot to mention during the video, you probably want to mesh some of these together, because if we move this right now, or if you grab just the circle, so you can move it out of there by mistake. So what you do is you select the whole item, do a select all, and then right click and do mesh boolean. This way it cuts it, and if you move it around, it stays where it's supposed to stay. So we want to take this piece, put it over here. I don't want to throw any of the original pieces away, so I'm just going to swap them around. The base, for example, let's put that over here temporarily. We'll swap this base for that one. And the speaker grill, we'll just pull that over here. Whoops. And we'll put that there. So get all your pieces lined up, because you don't want to print multiple times. So it's the speaker grill and the base that have to be pulled over. But I recommend keeping the original pieces. Don't discard them. When assembling the ESP8266 to the base, it's really important to orient the board as I show in this photo. It's also important to note where there's screws and where there are not screws. You can't put a screw where this white pin is. If you do, you'll see that there's a chip missing there. That was a diode. When I put a screw in here, I didn't realize that the edge of the screw was going to snap the diode off. So that's when I redesigned the support so it's just a pin. So don't put a screw here, because otherwise you'll break that off. So orient the board just like it is here. The antenna should be going down. This screw here is fine. It just misses that momentary switch. But this one, leave it alone, because otherwise I also broke the reset button off of this. I had the nut on this side, and the nut, when it was turning, snapped the reset button off. And then during testing, I had the head of the bolt on this side, and the head managed to break the diode off. So mount the board exactly as you see here. Looking at the other side of the board, just make sure you use that cone-shaped pin over here on the music board. Don't put a screw there. I was worried that the screw was going to short out the USB connector to pin 1 on this board, that the head was going to possibly touch it. So that little cone-shaped pin, it'll just keep that thing from wobbling around in there. Just push it in and it'll stay put. Once you have all the parts printed, what I recommend for assembly, I like to use E6000 and shoe glue, this type of glue, or the E6000 equivalent, for gluing the USB-C connector into the base. That type of glue is more like a paste. It won't run. Whatever you do, don't glue the USB-C connector in with super glue. It's like water. It's a good chance you'll get it inside the connector and then you'll ruin it. The switch, if you decide to put the switch in as a press fit, you won't need any glue for that at all. Now for gluing the plastics together, most likely this is not your first project, so you've got your favorite glue for the plastics. I like to use this tester's glue, this model glue. This works really well. I like to put dots on the plastic. I wait 2 minutes for it to air dry, and then I stick the pieces together. I hold them for about 20 seconds together, and then it's done. It'll stay put without letting go on its own. It's not really dry, but it'll hold itself together. But a key tip I want to give is the speaker. This front grill here, the green piece that has the hole cut in it, leave this for last. Don't glue this whole green piece in and the mesh, the silver mesh. Leave that completely unassembled for now. The reason being is I didn't do that. I glued this in right away. I would like to have some formal magnets in here to join the base to the shell here. And by having an access hole here temporarily, you can go in there with some tools and position your magnets so that the base will stay well stuck to it. Right now, I had to guess where the magnets were lining up and do a messy job to get these in there. If you have an access point through here, you can do a much cleaner job than I did getting some magnets in there so that that base will stay properly, set. And for the speaker, I definitely recommend using the shoe glue or the E6000. Don't use a super glue on that. It's too brittle. And this speaker is fairly heavy, so by gluing that with that type of a glue, if there's any flex or you drop it, that glue will give a little bit and it won't let go. If you use like a super glue, it's going to let go. Even the testers, I don't think I would trust the tester's glue for gluing the speaker to the plastic. I think you're going to be pleasantly surprised. When I first listened to this speaker outside of the jukebox cabinet, it didn't sound too good. I was getting a little worried that this is not going to work out. It is absolutely amazing when this speaker is in this cabinet how it resonates the sound beautifully in there. It's acting like a speaker cabinet, and it easily fills a very large room with a decent sound. I was quite surprised how good this works out with this little speaker. This is the schematic for wiring the 8266 to the music board. If you can't read schematics, it's really not difficult. Just follow the wires. Wherever you see a dot, that means the wire gets joined. So if you follow this red wire, when it intersects with the orange, that means nothing. It does not get joined to the orange wire. So wherever you see the dots, that's how you join it together. So in this case, we're going to take the V, which is the voltage from the USB-C. We're going to connect it to the power on the LED ring. Then it's going to go to the VIN on the 8266, and it's going to go to the 5-volt positive on the music board. So as you can see, there's not a lot of wires to be hooked up here, so it's very straightforward. Make sure you set the dip switch on the music board for off, off, on. And just a note on the USB-C connector, you cannot use the data minus data plus. Sadly, that USB-C type connector doesn't have the pull-down resistors in it to do the data ports. So it's strictly being used for voltage. For the next steps, we need a computer with a browser, and we're going to go to arduino.cc/en/software. This link will be in the YouTube video. Go to this website and look for the download button and install the Arduino IDE. Don't worry about the version. You could be watching this video 6 months from now and it's a different version number. Just take the current version of this IDE. Once you have that downloaded, I want you to run the application and install it. During installation, it's going to be making several prompts about installing drivers like USB drivers. Let it install everything it needs to install. If you don't let it install everything, it will probably not work correctly. Once you have it installed, I want you to go to this website, which is github.com/gquerying/jukebox. This will also be a link in the YouTube video. Once you have this page up, I want you to click this file here, jukebox.ino. Click that. Over here, towards the right, you're going to see those two square boxes. If you put your cursor over it, it says Copy Raw File. Click that. That now copied this program into the buffer. Launch the program that you just recently installed, that Arduino IDE. It should look something like this. It won't have this data here, but don't worry about that yet. Do a File New for New Sketch. It's going to have this program here. Just wipe that out. Take the program that's in the buffer. Just do a right-click paste. This is what we copied from before. This is the entire Jukebox code. So you should see something like this in your editor window. Once you see this, I want you to scroll down and look for the Arduino line that looks something like this with those slashes. When you find that, look for something like this from the File Preferences menu, install this additional link. I want you to copy this line into the buffer. So highlight it, right-click, and copy. Now go to the File menu, pick Preferences, and down here you're going to see Additional Boards Manager. Yours is going to be blank. I want you to paste that link into this window here, this item, and then click OK. But before you click OK, just make a quick note of your sketchbook location, just so you know where your documents are going to go. In my case, it's not on the default drive. Yours will probably be something like C:\user, something or other. That's fine. Just make a note of wherever that location is. So click OK. Now we need to make some changes to the IDE. Go over here to this icon here. That's called the Boards Manager. That board manager. So you go over here and type ESP8266, and you should only get one entry. And in your case, there should be an install button here. So install it. Don't worry about the version number. Take whatever the current version is. So install that library. It's usually a fairly fast install. Once that's installed, I want you to come over here to the Library Manager. That's this icon that looks like a bunch of books. Now we're going to type in Adafruit, ADAFRUIT _NEO, NEOPIXEL. The one down here called Adafruit NeoPixel. Don't take these other ones with the matrix and the library and all that DMA stuff. You want this one here. Adafruit NeoPixel. Again, it might be a more recent version, just take it. There will be an install button here, press it, and install this library. This is the only library you're going to need to compile this program. And the libraries are documented in the source code here. So once you have the libraries installed, so the next step is the Tools menu. You're going to go down to the board. You're not going to have the board set up yet since it's new. So you're going to pick the ESP8266 board over here. And you're going to pick node MCU 1.0, the 12E one. This should work for just about any 8266 board out there. With the board plugged into your PC, if it's not plugged in, you won't see a COM port. So plug your board into your PC with the USB cable and see if you see a COM port here. Like right now, it's not showing a COM port because I don't have it plugged into my PC. So I'm going to plug it in right now. After you plug it in, it should see it within about 5 seconds. Just close the Tools window down and refresh it. And you'll now see, in my case, COM3. It may not be COM3 on your computer. It could be COM4, COM2, COM5. Makes no difference. As long as you see a COM port, you're good. If for some reason, after doing this, you still don't see a COM port, go back to this source code. And in this line here, it'll tell you, if you can't see the COM port on Windows 11, it's typically a Windows 11 problem. Go to this website, download that zip file, and install it. Unzip and install it. I've been using this driver for years, and this works really well when the COM port's not working correctly. So when you have this connected, and you see the COM port, you're ready to compile. How you compile is easy. You come over here to this button that points to the right. You press it. It brings up this output menu. The stuff in red, don't worry about it. That's not an error. It's going to compile the code. It's very quick. It's already uploading the code to the 8266 board. And now it's resetting the board. And your board, if it's all hooked up with the LED ring and the speaker, is probably playing some music now. A quick comment I forgot to mention, there is one kink with the music board that I couldn't get around. The shuffle mode is always going to play the same song. I tried several tricks in the software to get around it. It didn't work. So then I decided I'm going to make a 1-second MP3 file and replace the song that it always plays with that 1-second file. And the second I changed the file on the SD card, it picked a different song to be the song that it's stuck on for the first song. So the only problem is when you turn this on, it's always going to play the same first song, and then the shuffle mode will work fine. Okay, so to sum things up, some of you might be curious why I didn't demonstrate the music. It's really simple. YouTube, with their copyright messages, they would ding you if I played any sort of music on that card that's copyrighted. I gave this as a gift to my mom, and she just turned 96 years old recently. And I wanted this to be a really simple, non-technical thing to use. And this is as non-technical as you can get it. She turns it on, and it starts shuffling through the music on the card. And make sure the card is 32 gig or less. For the filaments that I used a clear green from Sunlu for the band here. The silver posts down here is a silk silver from Sunlu. The rest of the colors were from Bamboo, and definitely remember to print that inside shell in a white so it properly reflects the LED around. If you have any questions, just leave the comments in YouTube, and I'll try to help anybody that is having problems compiling the code, or if you can't read the schematic, or there's some other issue, just leave a comment.